Now the next problem type is based on vertical projection from the ground. So here we are projecting a ball from the ground. A ball is thrown vertically upward with the initial velocity of 150 meters per second. So this velocity is 150 meters per second. The ratio of the velocity after 3 seconds and 5 seconds is x plus 1 by x. The value of x is.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
So in this question, let us assume upward direction is positive or downward direction is negative, right? And downward is negative. So initial velocity will be plus 150 meters per second. And the acceleration, since the ball is moving in gravity, so acceleration will be minus 10 meters per second square because it is acting in the downward direction. And we have assumed downward direction is negative. Now velocity is given as u plus 80. And it will be 150 minus 10 times t. So velocity at 3 seconds will be 150 minus 10 times 3, that will be 120 meters per second. And velocity at 5 seconds will be 150 minus 10 times 5, which is 100 meters per second. And this, so the ratio of these two, so 120 upon 100 is given as x plus 1 by x. And this is nothing but 6 by 5, or 5 plus 1 by 5 is equals to x plus 1 by x. So x is 5. So option 2 is the right answer. Now let us the next question. An object is thrown vertically upwards. At its maximum height, which of the following quantities becomes 0? So at the maximum height, velocity is 0. Acceleration is non-zero. Momentum. If velocity is 0, momentum is also 0. And okay, right, so which of the following quantity becomes 0? So momentum will become 0. Potential energy. So if we assume potential energy of the ball when it is on the Earth's surface is 0, then it will have increased potential energy. And acceleration is non-zero. So B can't be the answer. There will be a gravitational force. It is so D option is also incorrect. So option A is the right answer. Now let's see this illustration. It is a typical juggler problem. So let us see. A juggler throws ball vertically upward with the same initial velocity in air. When the first ball reaches the highest point, he throws the next ball, assuming the juggler throws n balls. So we have given frequency, right? So n balls being thrown in 1 second. The maximum height of the balls can reach. Okay, right. So let us see what we can do. So and he throws the next when the first one reaches the top, right? So first let us find the time taken by the ball to reach the topmost position. So here let's say the initial velocity is u. So if we apply first equation of motion, so v is equals to u plus at. So v is 0, u is u, and that is minus g. So we got the time, that will be u by g. So in u by g time, we are throwing the balls, right? And we know that, so one ball is being thrown in u by g seconds, and for throwing n balls, it will be ug times n seconds, right? And we know that we are throwing n balls, the juggler is throwing n balls in 1 second. So 1 is equals to u by g times n, or we can say u is g by n. Now we got the initial velocity with which we are throwing the ball, and we have to find the maximum height attained by the ball. So if you're throwing a ball with g by n, the maximum height will be v square is equals to u square plus 2as. So v is 0, u is g square by n square minus 2g, and the h maximum height. So h max will be, it will be g square by 2n square g, which is nothing but g by 2n square. So option D is the Right answer. Now let us see this question. A ball is thrown with a certain velocity so that it reaches a height h. Find the ratio of the two different times of the ball reaching h by 3 in both the direction. Okay, right. So first let us understand the question. So we are throwing a ball from the ground, and let us say the initial velocity is u and the maximum height attained by the ball is h. So that is given, and the ratio of two different times. So basically, if I consider a height which is h by 3, the ball will cross this height h by 3 two times. So let us say this point is O and this point is A, and while coming back again at point A, right? So let me show you two paths. So this is the first one. In the second case, it goes up and then returns. Okay, and again it is reaching the same point A at the same height. Let us say the time taken by the ball from O to A directly is t1, and time taken by the ball to reach A again will be t2. So we have to find t1 by t2. Okay, so that's what we have to calculate. So how we can do that? So let us apply second equation of motion, s equals to ut plus half at square. Now what we're going to do, we'll substitute s as h by 3 and u is the initial velocity, and we have given the maximum height, so we can find initial velocity in terms of h. So let us calculate that. So u is the initial velocity and the maximum height is h. So if we apply v square equals to u square plus 2as, so v will be 0. It is u square minus 2gh. So we got u as root 2gh, right? Okay, even you can, we know this result also. So u is root of 2gh, t plus half, and a will be minus g t square. Now we got a quadratic in t, and it will be having two roots. So we can say t1 and t2 are the two roots, right? Because it tells us what is the displacement of the ball from the initial position, and that will be h by 3 only. So now let us simplify this further. So I can write this as g by 2t square equals to minus root of 2gh times t plus h by 3. So we got this quadratic. So what is the sum of roots? So t1 plus t2 will be minus b by a. Okay, so we got this, and this can be written as root 8 h by g, right? And if you want to find the product of roots, so t1 t2, that will be c by a, so that will be h by 3 divided by g by 2. So it will be 2 by 3 h by g, right? Now we got t1 plus t2. Let us find t1 minus t2. So t1 minus t2 will square of that is t1 plus t2 square minus 4 times t1 t2, right? Okay, now let us substitute the value of t1 plus t2 and t1 t2 in this equation. So t1 minus t2 square will be equals to, it will be root of 8 h by g square minus 4 times 2h by 3g. So this can be written as 8 h by g minus 8 h by 3g. So this comes out to be, so 8 h by g will be common. So we have 1 minus 1 by 3, which is 2 by 3. So 2 by 3, 8 h by g. So it comes out to be 16 by 3 h by g. So we got the, so t1 minus t2 will be root of 16 by 3 h by g, right? Now since t1 minus t2 is positive, so what we can say, this T1 corresponds to this T2, right? And this T2 corresponds to T1. And we have to find the ratio. Okay, let me write it as T1 and this as T2, right? So we have to find T2 by T1. Okay, right. Now, let us use the equation 1 and the equation 2 to find T1 and T2. So if we add 1 and 2, okay, we have to find T1 and T2, right? So it will be T1 plus T2 divided by T1 minus T2, and this comes out to be root h by g will get cancelled out. T1 plus T2 is, that will be root 8 divided by root 16 by 3, or we can write this as root of 8 divided by 16 times 3, so that will be 2. So it is root 3 by 2. So T1 plus T2 upon T1 minus T2 will be root 3 by root 2. And if we use componendo dividendo, we will get T1 by T2 as root 3 minus plus root 2 divided by root 3 minus root 2. And if you look at the options, all the options are less than 1. Basically, they have found the ratio of T2 with T1, right? So T2 by T1 is root 3 minus root 2 upon root 3 plus root 2. So option 3 is the right answer. Now let us see the next question. A body projected vertically upward with a certain speed from the top of a tower reaches the ground in T1. So we have given a tower and a ball is projected vertically upward. So we are projecting a ball in the upward direction. Let us say the velocity is u. And it attains a maximum and then comes down and then hits the floor, right, at this particular point, and the time taken is T1. If it is projected vertically downward from the same point with the same speed. So if we are throwing this ball in the downward direction with the same speed, it will take T2 time. Now time required to reach the ground if it is dropped from the top of the tower. So if we are dropping this ball with the initial velocity 0, what is the time taken? So that's what we have to calculate. Let us say this is T3. So what we can do in this case, since time T1 is given, initial velocity is given, right? And let us assume that the height of the tower is h. So let us apply second equation of motion 3 times. So first let us apply for the first case, then for the second case, and then for the third case, and then we'll try to manipulate the equations. So if we apply the equation for the first case, if we consider downward as positive, then the initial velocity will be negative. So it will be h equals to minus u t1 plus half g t1 square. And for the second case, it will be h equals to plus u t2 plus half g t2 square. Now for the third case, h is equals to half g t3 square because u is 0. Now what we can do, let us eliminate u, right, in these in first two equations. How we can do that? Let us multiply the first equation with t2 and the second equation with t1, and then we can add these two equations. So when we add, we will get h times t1 plus t2 plus half g, so not equal, it should be equals to plus half g t1 t2 times t1 plus t2. So can you see we will be able to eliminate t1 plus t2. So this can be eliminated and we'll get h is equals to half g t1 t2, right? Now what you have to do, you have to compare this equation with this equation. So if we compare that, then t1 t2 comes out to be equals to t3 square. So t3 is nothing but the geometrical mean of t1 and t2. So option 1 is the right answer. Even you can remember this result also. Now let us see the one more illustration based on the same problem type. So we have given a ball is thrown vertically upward with a velocity 19.6 meters per second from the top of a tower. The ball strikes the ground after 6 seconds. So we have given time of flight, and the height from the ground up to which the ball can rise will be. So we have to find the maximum height attained by the ball from the ground. Now let me first draw the diagram here. So this is the tower, and from this tower we are throwing a ball in the upward direction. So it goes up, attains maximum height, and then comes down. And the time of flight is 6, and the height of the tower is not given to us. So let us assume that the height of the tower is h. And initial speed of projection is also given, that is 19.6. So that is 19.6 meters per second. Now I'm going to apply, time is given, right? So I'm going to apply second equation of motion. So s is equals to ut plus half at square. So by using this equation, we'll be able to find the height of the tower. So I'm assuming downward direction is positive. So h is equals to minus 19.6. T is given as 6 plus half g is 9.8 times t square, which will be 36. So this will give us 18. Now from this 9.8 will be common. So we'll be having minus 12 plus 18. So that will be 6 times 9.8. So we got height, and now we have to find the height from the ground. So what is the maximum height attained? So again I can apply second equation of, or you can say we can apply the third equation to find the height attained by the ball, maximum height attained by the ball from the top of the tower. Let me call this as small h. So we can apply v square is equals to u square plus 2as, and v is 0 at the highest position, u is 19.6, and I have taken upward as positive in this case, so downward will be negative. So 2 times minus 9.8 times h, and so this comes out to be 19.6 times 19.6 divided by 19.6. That will be h. So it comes out to be 19.6, or you can say it will be 2 times g. So we got small h, we got a capital H. So the maximum height attained by the ball from the ground will be h plus small h, which is 6g plus 2g, which is 8g, and it will be 8 times 9.8. Okay, and this value is given as k by 5. So this comes out to be what? So it will be 8 times 49, that will be k, and it will be 392. So k comes out to be 392. So 392 is the answer of this question.